right, let's talk some more about environments. So we talked about environments in the context of a local environment and the global environment. There's a little bit more to it. So let's get into some of the details there. The environment is actually itself a data structure. It's the data structure that powers scoping. Basically, the job of an environment is to bind names to values. You can think of an environment as basically like a bag of names, where each name in that environment then points to an object stored in memory. So the computer, keeps values and whatever stored in memory, and then the way you access those values is by using the name that's pointing to that object in memory. And those names are stored inside the environment. And so the data structure for that is the environment. So you can actually create your own environment using the function new.environment. And so here we're going to create a new environment called E. And within E, we're going to have the names A, B, C, and D. Now, they don't have to be one letter. Obviously, we can have names like, function name, whatever it is, right? Some vector or whatever that you want to call it. But here, A gets bound to an object with the value false, the vector with the value false. B gets bound to a character vector. C gets bound to a numeric type double vector, and D gets bound to an integer vector. And these names exist inside this gray box, which represents the environment. Okay. So as with everything in R, environments themselves are also objects. The syntax to work with the environment is similar to a list in that you can use double bracket, double square bracket, or the $ to get the values. So you can ask type of E, and it will say it's an environment. You get the values by using E $C, $ notation, or E double square bracket, and then you put the name in, quote D, okay, inside double square bracket, and does that, okay? However, environments are inherently unordered, so you cannot say, hey, give me the first item, right? In a list, you can say, hey, give me the first item, double square bracket 1, and it will give you the first item. Environments are like bags, okay? If you go into your backpack and I say, get the third item in your backpack, it's kind of a nonsense question, because if things are just kind of floating around in your backpack, which one's the third? Which one's the third item, right? If you have like a bunch of erasers or tennis balls or something in your backpack, and I say, hey, get the third item, it doesn't quite make sense. Okay, so you can't use ordered operations there. You can take a look at what kind of what the names are you have in your environment by using the ls function. So ls, often we use that in the global environment and lists off all of the objects inside the global environment. But if you have a specific environment like environment E, you can do lse, and it will give you the names inside that environment. And then there's another function, ls.str, and that will give you a little bit more detail, basically on the structure within the environment. Okay, similar to how you can get the structure of a list and things like that. Basically, you get more details on the environment itself. Okay, again, there are similarities between environments and lists, but again, environments themselves are unordered, and there are some major differences in that you can't use a single square bracket with an environment. Okay, and then if you set an object to null in an environment, it does not actually remove the environment. Okay, it just sets that value to be the null object. If you want to remove an object from an environment, you have to use the rm function. So this is kind of how we delete objects in the global environment. You just do like rmd, or if you have it within the environment, you do rmd comma, and then you specify the environment that you want. And so here we can see that setting null to E $D, D is still there. Okay, however, using rm on D gets rid of that. Every environment has a parent environment, which is basically another environment. Okay, In these diagrams, this blue circle points to the parent environment. Okay, the parent is used to implement lexical scoping. That is, if R can't find an object in the current environment, can't find the name in the current environment, it looks into the parent environment and so on. Okay, and so you imagine just kind of a chain of a bunch of environments until it reaches the top level environment. This is the only environment that doesn't have a parent, and that is the empty environment. Okay. So there are kind of 4 special environments, or I guess 3, and the environment is always just the current environment. When you ask for a global environment, that's going to be the global environment or your workspace. This is basically the environment that you normally work in when you start up R and you create vectors and stuff. It all goes into the global environment. The global environment has a parent, and it's a little bit odd to think about, but the parent of the global environment is whatever library is attached last. Okay, the most recently attached library is the parent of the global environment. I'll explain that. It's all part of the search path. Okay, you also have what's known as the base environment. It is the environment of the base package. That's kind of the when R gets loaded, it first loads the base package, then it loads a bunch of other packages like stats and things like that. The parent of the base environment is the empty environment. The empty environment is the ultimate ancestor of all environments. It's like the parent of the parent of the parent of the parent until the very end, and it is the only environment without a parent. Okay? And then finally, the environment is just the current environment, whichever one you're working in. So you can ask for the search path, okay, by typing in search parentheses, and that will list all of the parents of the global environment. This is called the search path because when R can't find something in the global environment, it starts searching for that thing up the search path. So for example, when you start up R, you never create a function called standard deviation. Okay, you never create a function called SD, but you can ask for SD. You can ask for the standard deviation of a set of numbers or something like that, and the way and it finds that I believe in package stats, I want to say, but then other functions like the function you use to create a list, that shows up under base. Okay, other things, there's data sets and graphics and things like that. Here, when I knit things, it loads up a package, or I think I loaded a package knitter. So this is the search environment. So the last package I loaded was knitter, and that's actually the only package I think I loaded as far as creating these slides go. But then these ones all kind of get automatically loaded when you start up R. Okay, and so the very first thing is base. This is going to be things like has the function C that we use to create vectors. Okay. And then we have other things. I think methods contains functions for like creating factors and stuff. I think don't quote me on that. And then you have functions like LM that exist inside package stats. Okay. So this is how the search path looks, or you can visualize it this way. You have your global environment. Whichever package gets loaded comes in here. It keeps going up until you reach the base environment. And then the base environment has the empty environment as its parent. Okay, when you call library and load another function or load another package, okay, so let's say you call library on, say, ggplot, okay, that's going to contain functions like ggplot. I guess the library is ggplot2, contains functions like ggplot, and that gets in here, and so that way you can call in R, you can ask for ggplot, and it creates a thing, and it will find it inside this package that you loaded. Okay. If you don't load it, all right, and you're back here in ggplot2, the library is not loaded, and you ask R, hey, I want to create a function with ggplot, it's going to say, hey, that's not found because it's not in the search path. So you need to load that library. Now it finds it. Now it's in the search path, and it's able to use that. Okay. We talked a little bit about this already, but we'll visualize it here as well. So a lot of the environments that you end up dealing with are created as a consequence of using functions. Okay, every function has 4 types of environments associated with it. You have an enclosing environment, a binding environment, an execution environment, and a calling environment. Okay? The enclosing environment is the environment where the function was created. Every function has just one and only one enclosing environment. As far as the 3 other types of environments, that is binding, execution, and calling, there could be 0, 1, or possibly multiple environments associated with each one. Okay? Binding a function to a name with the assignment operator defines the binding environment. That's where the name of the function exists. Calling a function, when you execute it, creates a temporary execution environment that stores the variables created during the execution. And then every execution environment is associated with a calling environment, and that one tells you where the function was called. All right, it sounds like a lot of stuff. Let's just kind of work through an example in a moment here. Okay, so when you create a function and you write it, that gains a reference to the environment where it was made. This is the enclosing environment, and that's used for lexical scoping. Then when you name the function, the environment where the name exists is the binding environment. In most of these cases, the enclosing environment and the binding environment is going to be the same environment. Okay, so here in the global environment, y gets the value 1. Okay, the name y is associated to the value 1 in memory, and then the name f is associated with this function that gets created. This function, it's a function of x, and it's going to return x and y. And we can ask, hey, where is the f located? Which environment is located? It's located in the global environment. Okay, so the function is created in the global environment, so that's the enclosing environment. The name f exists in the global environment, so that's also the binding environment. Okay. In the search path, however, we see that the parent environment of a package varies kind of based on what other packages have been loaded and in what order they've been loaded. Okay, so does that mean the package would end up finding different functions if they're loaded in a different order? Okay, so if you think about, right, because if the parent environment, the order of the parents' environments are different, right? If you have a, let's say, let's say there's multiple, you can think about it kind of like different friend groups or something, and there might be multiple people named Joe, okay? And if the order in which you're searching for Joe differs, right? You have friend group 1, friend group 2, and friend group 3, and you change the order of them. When we ask for Joe and you search for it in a different order, you might end up picking out different things. And would we run into that same kind of problem in R? Okay. Well, the way R handles this is it uses basically what's called namespaces. Okay. So if you look at the standard deviation function, the standard deviation function is actually defined in terms of the variance function. So first, basically, when you call for the standard deviation of a vector or something, okay, R is going to try to calculate the variance of it, and then it's going to return the square root of it. Okay, so how do we make sure that we're going to use the correct variance function or something that later on, if I were to create another function called var, which not a good idea, but there's no rules against it. Okay, if I create another function var, or I load another package that has the function var, is this going to affect how things work? Okay, and this is how namespaces are used for package creation and kind of making sure packages work, right? So the distinction between the enclosing and the binding environments is important for functions inside packages. So to kind of make sure that every package works the same way, regardless of what other packages are attached by the user or in what order they're attached, packages require an internal environment called the namespace in which the package functions are defined. So the package functions are defined inside the namespace, and that way when we're looking for the enclosing environments and stuff, it's always going to find the correct name. Okay, so every function in a package is associated with basically the package environment and the namespace environment, and it's going to find the name of the function in the search path. Okay, that's going to be kind of your binding environment. It's going to find the names that way. But then the functions themselves are defined in the namespace, and that's where that's how it keeps the references to the other packages correctly, or other functions correctly. We have the double colon operator. The double colon operator is used to kind of access a function directly from a package. So the package environment is the external interface to the package. So this is the environment that R uses to find a function, okay, and it's and the parent of the package environment is determined by the search path, okay, and so if you load your packages in a different order, okay, if one of those packages has functions that have the same name as other functions in the package, the one that gets loaded most recently is the one whose name is going to be found first. Okay, so there is a function mean in the base package. Okay, there's also a function mean in the Mosaic package. So normally, if you start up R and you ask for the mean of something, it's going to find, and you don't have any other packages loaded, it's going to find the mean function in the base package. Okay. However, if you load the Mosaic package, okay, that's going to become the new parent environment of the global environment, and then when you ask for the mean, it's going to find the mean function in the Mosaic package, and so that will mask the mean function in the base package, and R will use the mean that's in the Mosaic package. Now let's say you want to use the mean in the base package. Okay, the way you can do that is the double colon operator, and you say base : mean, and that will refer to the mean function in the base package, and you'll access it directly, and not in the order. Okay, so it's kind of like using someone's first and last name, right? So if you have multiple people named Joe, okay, and you are very kind of aware of like the order of your friend groups and stuff, and in your current friend group, you're talking about Joe, you'd think about the Joe that's in your kind of current circle, that might be in the present room. But if you want to talk about a different Joe, you might use their last name, right? And you'll say Joe Thompson, and you go, oh, okay, that's not the Joe that's in our current friend group. That's the Joe Thompson that's over there that we're also familiar with, but we are referring to that. And that's basically what we're doing. We're basically using the name of the function and its kind of package name to do that. Okay, so that's the double colon notation that allows you to access objects that might be masked by other things. Okay, the namespace environment is the internal interface to the package. This package controls how we find the function. The namespace controls how the function finds its variables. So when the namespace environment of a package often contains internal or non-exported variables, bindings that allow internal implementation details to be hidden from the user. Basically, when we call standard deviation, okay, R finds it using the binding environment, finds standard deviation and says, okay, here's the function, okay? But this function makes reference to the variance function, and it's going to use the lexical scoping as defined by the namespace. Okay, so let's just take a look at a very simple function, and let's talk about how this works. So every time you call a function, a new environment is created to host the execution. The parent of the execution environment is going to be the enclosing environment of the function. And once the function is done, this execution environment is thrown away. So here we have a simple function, h, okay, inside h. So h is a function of x, and h is, inside h, we assign the name 2 to get the value, the name a to get the value 2, and then we get, it returns x plus a. And so we're going to call h, pass the value 1 into the argument x, and then whatever it returns we're going to assign to y. So how does this work? So when we call h with the value 1 as x here, it creates an execution environment. Okay, this is the execution environment. The x gets the value 1. So this is just what happens. Basically, we're running this very first line of code. When you run h of 1, it just runs the very first line of code, and it just basically assigns, it creates an execution environment. It assigns the name x to the value 1. Okay, the next line is going to then assign a to the number 2. Okay, so a gets bound to the value 2. And then the last line here, it's going to add x and a, and it's going to return that value 3. As soon as it returns that value 3, this execution environment, poof, it disappears. Okay, it disappears, and then it assigns that value 3 to y. Okay, and so this is now the global environment. Global environment has value y, which gets the value 3, and then h still points to this function. It's a function of x, but the execution environment that was here disappears. Okay, when you call a function, it creates that execution environment. The execution environment has two parent environments. Okay, it has the enclosing environment, and it has the calling environment. Okay, so this execution environment, when it looks for things like a and whatever, it comes from the enclosing environment. Okay, so if you create a function in the global environment and you call the function in the global environment, then the enclosing environment and the calling environment are the same. But sometimes you call a function from inside another function, and in that case, the calling environment and the enclosing environment are different. The normal scoping rules in R use the enclosing environment. So if the function is looking for values, it uses the enclosing environment where that function is defined. Okay. R, however, also supports dynamic scoping, where you can then look for values in the calling environment. Okay, and you achieve that by using the function get. So, for example, if you wanted to get the value y from the calling environment of the function rather than the parent or the enclosing environment of the function, you can use get y, and you get it from the parent frame, and that will use the calling environment. And I'll show you an example of that in the next video.